So here we are with a very interesting problem type. As you can see, ingenious sequences based on expansions. So what we mean by the title, let's focus on the question. It's a sample question from the problem type. Given a1 is the maximum value of fx, where fx is okay. This brackets, there is something missing, represents the greatest integer function. This bracket represents the greatest integer function, and there is a relation, a kind of a recurrence relation between the terms an, and we need to find limit n tends to infinity an. Fine, fantastic. So it's a very easy question, basic question. Just to give you the idea of this problem type, we have chosen this basic question. We'll solve two questions from this problem type. So let us first solve the question. Given the maximum value of fx, so we all know that sin x lies between, so the box of sin x will lie between 1 to -1. The same applies. So what we can do is just add to 2 plus sin x lies between 3 to 1. 1 over 2 plus sin x lies between 1 by 3 to 1. So the maximum value of fx is 1, right? So a1, which is the maximum value of fx, is nothing else but 1. This is one given information, and we have a recurrence relation. So using the recurrence, this recurrence, actually it is nothing else. It is in the very simplified form, in telescopic form. They could have used some little bit modification to make the problem a little bit more interesting, but as I'm emphasizing that this is a basic problem to give you idea about the problem type. So the first problem is very easy. Second problem will boost up the level little bit boost up the level. So a1, now have the relation between them. So let us write a2 minus a1 minus 1 by 2, a3 minus a2 will be 1 by 3, right? So on, we'll have an minus an minus 1 will be minus 1 whole to the power n plus 1 over n, right? And we'll add them up. We'll add them up. This is continued, okay? This is continued. We'll add them up. Adding them, what we will get? All other terms, as you can see, will get cancelled out. A2, A2, A3, because here you will get A4 minus A3, right? The next term. So this is cancelled out. This will be also cancelled out, because here we will get what? An minus 1 minus an minus 2 equals to something. So that will be cancelled out. Only an and a1 are not going to be cancelled out. An minus a1 is equals to minus 1 by 2 plus 1 by 3 and so on, right? This will be continued. So an can be written as an can be written as, because the value of a1 we know is 1, 1 minus 1 by 2 plus 1 by 3 minus 1 by 4, so on. It will be a continued and converging series. Now the question comes in our mind, how will we simplify this? Some will try some kind of you know telescopic method, some will try telescopic, some will try geometric progression, and different types of method they will try. But since we are considering this problem in the section of sequence and series, you can say ingenious sequence and series, this is going to be some kind of mystery for us. That's why we're considering this, right? Actually, you won't be able to solve this problem so simply if you don't know the exact approach of this problem, and that's why this problem type series is being introduced only for certain problem types, to bridge the gap between certain problem types which are not discussed in the regular classes. Any kind of regular JE classes are discussed in the good batches, only in certain good batches, but not in all the classes. So this is nothing else but the expansion of ln2 log e base 2, right? This is nothing else but the expansion of log e base 2. And when n tends to infinity, we will get this series. The answer is ln2 or log e base 2. So how will we identify this? See, for that we need to memorize certain important expansions. We need to memorize certain important expansion. Let me just write the expansion of ln 1 plus x, that is x minus x square by 2 factorial, sorry, not 2 factorial, simply 2 plus x cube by 3 minus x to the power 4 by 3. Expansions are very important. Now put x equals to 1, you will get ln2 as 1 minus 1 by 2 plus 1 by 3, so on, continued, right? Expansions are very important. Certain expansions like ln2, the binomial expansion of 2 to the power n, right? Apart from the general expansion, like lot of us have memorized this expansion of ln 1 plus x, but expansion with certain values of x are also important. Now there is very little probability that someone is going to ask you question regarding expansion of ln3, right? Because that is going to be very difficult for us. But yes, for x equals to 1, for any expansion, any such expansions, at least we should also memorize the expansion, or we don't need to memorize, we just need to overlook the look at the expansion when the value of x is 1. Say we have a lot of other expansion. Let me show you few important expansions. Like this is sine x, so we should know the expansion of sine 1 as well. There is a possibility, right? 1 is the most common number, you can say. Similarly, you can memorize the expansion of cos x. I'm just showing you all those expansion. Just have a look and write it if you don't know the expansions. This, all of these are very important expansions, right? Especially the expansion of 10x. You won't be able to catch some kind of a pattern here. That's going to be very difficult for us. then log 1 plus x, already we have shown this. Actually here the base is e, base is e, and this is the expansion of e to the power x. Again, this is very important. So the expansion of e is also important, that is e to the power 1, 1 plus 1 plus 1 by 2 factorial plus 1 by 3 factorial, so on. This is the expansion of a to the power x. This is also very important expansion. This is nothing else but infinite gp, we all know, right? This is nothing else but an infinite gp, mod x less than 1, sin inverse x, tan inverse x. Okay, so now let us solve the next question. For this question, just try to solve this question. Okay, now I hope you all have tried. So let us give you the first hint of this problem. This is the first hint of this problem. This is the first hint of this problem. So you can again give a try for 2-3 minutes and then come back to watch the solution. So let us solve it. 1 plus 5 by 8. Let me remove it. Let me remove it. 1 plus 5 by 8, 5 into 8, 8 into 12. So let us try to look into some pattern. As we can see, these values are increasing by a factor of 8. Okay, leave this one for some time. We'll sort it out. This is increasing by 4. This is increasing by 4. This is increasing by 4. This is increasing by 3. This is increasing by 3. This is increasing by 3. Correct? So let us try to figure out the general term. Let us try to figure out this term. Okay, let us focus on this term. This is going to be the fourth term. T4 is equals to 5 into 8 into 11. So one thing we can also observe that we can take 4 common. So this is 4 cube, 2 into 3 into 4, right? And here we have 5 into 8 into 11. 5 into 8 into 11. We can write it as 4 factorial over 4 cube. Now whenever this factorial comes in general term, like whenever we can see this factorial in general term, one thing that should click in our mind is that can we apply here some kind of expansion of as we have seen in the expansion of sin x, also we have the factorial term. Most of the expansions will find this factorial terms, and the most common for us is the expansion of 1 plus x whole to the power n, right? Most common for us. So what we will do here, these terms are a little bit confusing. As we can see very clearly, they are increasing by a factor of 3. Increasing by a factor of 3. So what we can do, here we have a 4 cube, right? 4 cube. And if we want to use the expansion of 1 plus x whole to the power n, right? So we need to be a little bit more careful. Since these terms are increasing by 3, let us divide them by 3. What is the benefit that we will get after dividing them by 3? See, what happens here. Just a minute. fantastic. Okay, sorted. So let us come back to the problem. Let us divide them by 3. What we will get? 3 by 4 whole cube, 4 factorial, right? And this is the t4th term. What is the benefit? Now it is increasing by 1, right? Now it is increasing by 1. So this is one benefit we are getting from here. So what we can do is that if we consider all these numbers as negative multiplying by minus, right? 5 by 3 minus 8 by 3 minus 11 by 3 minus 3 by 4 whole cube over 4 factorial. Now they're decreasing by minus 1. So can we write them? Minus 5 by 3, 5 by 3 minus 1 minus 5 by 3 minus 2. Now since this is the t4th term, we'll write it as a 3 factorial into 4. Why we're writing a t factorial into 4? Because the power is 3, right? And for binomial, that is our target here, we should always fix to the motivation. Now why I'm saying that binomial? See, first you have a power, kind of power expression. First you have this expression, then you have factorial, and now you have some kind of if we consider this as n, then we have n into n minus 1 into n minus 2. So it is a very much similar to the expansion of 1 plus x whole to the power n. Apart from a small difference, what is the small difference? Can we observe it? Can we observe it? So here what are the considerations that we are making? This is x, right? And the value of n is minus 5 by 3. So apart from this, small considerations, so the expansion, let me write the expansion of 1 plus x whole to the power n, 1 plus nx plus n into n minus 1 by 2 factorial x square, so on. See, one thing, this is the third term, right? Third term. But here what we are getting is that we are getting 2 factorial and not 3 factorial. But here in our expression we are getting 4 factorial, right? 4 factorial. So this is the only problem that we are facing right at this moment. And how can we avoid this problem? Any ideas? Yes, fantastic. So what is the idea that we are going to use it? If we integrate this expansion, with respect to x, right, what we will get in the right hand side? X plus nx square by 2 factorial plus n into n minus 1 x cube by 3 factorial, so on. This will be continued, right? So now we can see that in the t3rd term we're getting this 3 factorial, but here is a problem. Here the power of t3rd, here is a problem. Here the power of the third term, the power of the third term, t3 term, t3 term is x cube, right? But what we can see in our sum, the general term, the fourth term that we considered, the power was 1 less than the value of r, right? 1 less than the value of r. So what we can do is that we'll integrate this LHS side also, the left hand side. and after integrating this, what we will get? 1 plus x whole to the power n plus 1 over n plus 1. We can take 1 x to the left hand side. 1 plus x whole to the power n plus 1 over n plus 1 multiplied by x equals to 1 plus nx by 2 factorial plus n into n minus 1 by 3 factorial x square plus. That is our fourth term, right? I'm not going to write it further. 4 factorial over x cube. This will be continued, right? And that was the required expression that we are getting, where the value of n is minus 5 by 3 and the value of x is 3 by 4 minus 3 by 4. Just put the value and check that we are getting our required sequence. Minus 5 by 3, 3 by 4, 3 3 cancel, 8 4 into 2 plus 5 into, and here we will get 8 8 into 12, so on. That is the required sum. So this is our required sum. Put the required values here, you will get the answer, right? So now at this point, I guess you are clear that what is the intention of this, what I have written here. Ignore that. Now at this point, I hope that you all have understood that what was the intention of these ingenious sequences. See, we have seen the application of expansion in limits, right? We all have seen, those who have studied limits, they have seen the application of expansion in limits, that whenever we get certain kind of problems, actually this is the last approach that we use in limits, that all the approaches we have tried, we are getting nothing, so just put the expansion, simplify it and find the value. So this is obviously the last method that we choose in limits, and that is the point that we should keep in mind, that not only this kind of applications can be asked. What is our thinking till now? What not till now, what was our thinking till now? That we will be asked only about the expansion of sin x. But why we cannot think that they can also give us this value, this value, this value, in such a way that we won't be able to identify it? If someone gives us 1 minus 1 over 3 factorial plus 1 over 5 factorial, continued, some will try telescopic, some will try this and that, but the answer is what? Sine 1. So why we cannot think in the reverse way? Because we haven't seen such kind of problems before. Most of us haven't seen. That was the motivation of this kind of a problem type series. Here the level of the problem will be not going to be very difficult, but the concepts will be really good. So this was a very interesting problem type. Thank you.